Professor Bialis here. In this video we're going to be talking about section 9.3, absolute value inequalities. Now, just like with 9.2 when we dealt with absolute value equations, the initial setup and breakdown of the problem is going to be the most important thing. Okay, so in this case there's actually going to be two different breakups depending on what type of inequality you're dealing with. So let's look at the breakup first and then we'll jump into some examples. So the first type of scenario you're going to see is when we have an absolute value that is less than some sort of expression. Okay? Now, when it's a less than, I want you to mispronounce this a little bit just to help you remember. Less than, I want you to say is less than. That and tells us that we are going to be creating a conjunction. Now, this conjunction is going to be one of those three-sided inequalities. Now, this is how you do it. I'm, just like with the equations, going to start by simply dropping the bars. That's it. After I drop the bars, I would then drop the bars, change the sign, but I'm going to do it differently here. I'm going to use this as kind of a clue to say go that way. I'm going to copy, change the sign. Okay? So, why am I doing that? Let's say we have something like this. Let's say absolute value of x is less than 3. Okay, if I follow that just basic framework, I would drop the bars, then I would copy, change the sign. Okay, so if I were to go on a number line, I would be using values in between -3 and 3. Okay, now why do I stick with that? Because I want values that are going to, after I take the absolute value, going to be less than 3. Well, obviously I wouldn't go here because automatically those are bigger than 3. And I wouldn't go here because if I have, let's say, a -5, that's less than 3, but when I take the absolute value, that shoots me back over here into that region where I don't want to be. So I need to cap it off on the positive end, and I also need to cap it off on the negative end. Okay, so again, I drop the bars, copy, change the sign. Okay, now this really doesn't deviate from the equation layout that we had because, again, I drop the bars, and there I drop the bars, change the sign. I had to flip that inequality symbol, though, making the a smaller here but the a bigger there, because once I mess with signs, I have to mess with that relationship of the inequality. Okay? So, let's go to our second scenario, which would be when we have an absolute value that is greater than some other expression. Now again, I want you to mispronounce this one as well, as a great or than, telling you to use a disjunction or an or statement. I'm going to start out the same way. Drop the bars. But now it's saying go that way. Okay? So it's a great or than, and this is where I'm going to drop the bars, change the sign, but again, when I mess with the sign, I'm going to mess with that inequality symbol, and I have to flip it. Okay? Now be careful, because as you're writing it like this, that negative number typically is listed first, so we're kind of doing it in opposite direction, but that gives a nice flow to how we build this. Okay? Again, let's look at more of a concrete example. Let's say absolute value is greater than 5. If I just follow the motions, I would drop the bars, then I would drop the bars, change the sign, and flip that. And this is a great or then. Now how would I graph that? What would that look like? I have a -5 and a 5. I have an open dot and I'm bigger. I have an open dot and I'm smaller. Now why is that the case? Okay, if I want to be bigger than 5, obviously numbers bigger than 5 would fit. Why do these negatives work? Because when I take their absolute value, these really big negative numbers turn into big positive numbers that are greater than 5. Okay, so again, that's the reasoning behind it, but as we're getting deep into these problems, really, it's just drop the bars, copy, change, or if it's a great or then, I drop the bars, change the sign, but also flip that symbol. Okay, that's pretty much it. From here on out, we're just going to go through a bunch of examples and then see how this kind of plays out. There might be a few curveballs in there that I want to show you, but this is really where it's at. So let's look at a few examples. Okay, we're just solving this inequality. So first thing we're going to do, we need to have that absolute value alone, just like we had with equations in the previous section. Okay, so we have that here. So I'm going to start by dropping the bars. No matter what, I drop the bars first. Okay. After that, it's a less than. Now notice the or equal to. The or equal to doesn't change anything. It just gets carried out throughout the problem. So if I was back here, if that's how I started, I would just carry it through. Same thing here. Just carry it through. Nothing else with it changes. So I drop the bars first, but it's a less than. So I'm going this way to copy, copy, change the sign. Copy, copy, change the sign. And again, what that does is it keeps me less than here, but it also caps me off on the negative side, because the more negative I get, that absolute value kicks me out to being actually bigger. And then I solve. I add a 2. So I have 1 less than or equal to x, less than or equal to 3. Okay? If you want to graph, you can, but if they just say solve and they want the interval notation, when it's a 3-sided inequality like this, as long as this number is smaller than that, and I'm getting bigger as I go across, I know my shading is going to be between those two values. And that's it. Okay? Again, the key here is knowing to take this and write it like this. After that, we're just solving that compound inequality. Let's look at a few more examples. Now, the first thing that we should be worried about is getting that absolute value alone. That's the very first thing. So I'm going to do that by adding an 8. And we got that. Okay. Now, in this case, I start by dropping the bars. And then I read that as a great or then. So or, it's telling me to go that way. The second inequality, I just drop the bars, change that sign. But when I mess with the sign, I change that symbol. And then at this point, all I have to do is solve both of those. Okay, so the first one, I'm going to add a 3. And then I'm going to multiply by 5. Okay, the next one, I add a 3 again. And then I multiply by 5. And we're there. Now again, be very careful, because when we do graph this, this number typically is going to be bigger than that. So we just have to be aware of needing to flip that. So I would graph this, okay, and then interpret what we have at the end. So what I have is a -5 and a 35. This is going to be a closed dot, and I want to go bigger, smaller than the -5. And then here it's going to be a closed dot, but I want to go bigger than the 35. Now, these are not overlapping, but that's okay, because remember, this is a disjunction because of that or. So I'm just looking, where's their shading? They're shading from -infinity to -5, and then 35 to infinity. Brackets here. And there we go. Okay, so it just comes back to section 9.1 when we're solving compound inequalities, but we need to make that compound inequality first. That's really what this section is all about, is going from this to this. That's what our focus should be on. Okay, how about some special cases? Let's say we have something like this. Let's say we have absolute value of 2x plus 3 is less than a negative 5. Okay, now why is that a special case? Because we have a negative. Okay, now when we have negatives and absolute values, stop and think about what it's saying. An absolute value will always work out as either a positive or a 0. I have whatever I plug in for x. This side will be positive or 0. Will a positive number or a 0 ever be less than a negative 5? In this case, no. It will never happen. Therefore, no solution. Okay? If you don't see that right away and you work it out, I want you to see what that looks like. Okay? Because if we say, okay, I'm just going to go ahead and drop the bars, it's a less than, so I go this way, and then I change the sign. Does that make any sense? To go from 5 and get bigger to a negative 5? No, that's a false statement, okay? I don't want you to even get to this point. I want you to just look at it and say no solution. But even if you take it a step further, there should be another red flag saying, stop, this isn't working out. Okay? What if it was like that? Now that's a little different, okay? Because you have a positive or a 0 bigger than negative 5. Okay? Don't just automatically say, okay, it's a negative, it's no solution. Okay, that's true for equations, that's true for a less than. But here we're saying a 0 or a positive is bigger than a negative. That's always the case. So in this case, we're going to have negative infinity to positive infinity. All real numbers will work in this situation. Okay, so again, if it's an absolute value equation equaling a negative, that's no solution. If it's an absolute value inequality where it's absolute value less than a negative, that's no solution as well. But if it's absolute value bigger than a negative, that's negative infinity to positive infinity. I don't want you to just blindly memorize those. Think about it like I did here. I think and say, wait a minute, positive bigger than a negative? Well, yeah, that's always going to happen. And we have that. Okay? Now, one other scenario that I want to show you is when we have a 0. Okay? When we had the equation, absolute value equations equal 0, we just dropped the bars and solved it. Okay? But here with the inequality, we got to be a little bit more careful. Okay? I'm going to keep it simple and I'm going to keep the numbers consistent so you can see really how just that inequality symbol can change things. So let's say I have absolute value of x plus 3 is less than 0. Okay? Actually, let's start with less than or equal to 0. Now, when they say less than or equal to, one of those has to be true. Okay, for the whole entire statement to be true. This again will be positive or 0, no matter what I plug in for x. Positive or 0, smaller than 0. Will that ever happen? No. It's either going to be bigger than 0, or it could be equal to 0. So in this case, I want to know when that's going to happen, because that will work. I can never make the less than 0 part work, but I can make the equal to 0 part work. So I'm going to subtract 3, and that turns into a single number that we're going to use as our answer. Okay? What about this? How about x plus 3 less than 0? Will we ever be able to plug a value in and make that less than 0? Okay, if I plug a number in, that's going to be positive. That's not less than 0. I could plug in a negative 3 and make it 0, but is 0 less than 0? No. So in this case, no solution. Okay? Very different outcome, and all that's different is that or equal to part. We have to really pay attention to the details when we have a 0 involved. What about the other two possibilities? How about that? I have an absolute value that will either be positive or 0. Positive, that means you're greater than 0. 0 equal to 0, yes. So no matter what I plug in, I will either be greater than 0 or equal to 0. So in this case, anything and everything will work. How about this? Okay. Now, we want that absolute value statement to be bigger than 0. Okay, that means positive. No matter what I plug in there, I'm going to be positive, correct? But I could also be a 0. So this is where we got to be careful, because I do not want that to happen. Okay, because I'm either going to be positive, which would work, but if I'm 0, that's not bigger than 0. So what I need to do is exclude that negative 3. I do not want to be equal to negative 3. I can be equal to anything else, because then this is going to end up positive. But if I'm equal to negative 3, no good. So how do I write that? Graphing this would say that I can be anything here and anything here, but not negative 3. So I would write negative infinity to negative 3, but not including negative 3, and negative 3 on to infinity. And there we go. Okay? So, it's not as cut and dry with inequalities when there is a 0 involved. Okay? That doesn't mean you have to memorize these scenarios or anything like that, but just think about them. Okay? This doesn't come up too often, but I want you to be prepared if you ever come across it. Otherwise, for the general portion of this section, we have these two scenarios right here. Okay? Don't try to get too creative with the expressions. You write them out, go through the solving. Okay? So, as always, work hard. Let me know if you have any questions. I'll see you next time.